Hey, today we're going to continue our discussion about probability, and we're going to come back to something that we did when we talked about the introduction to probability, and that's the multiplication rule. So whenever we want to find out the probability of what I call an AND probability, so the probability of event A and event B happening, we're going to use the multiplication rule. If those two events are independent, meaning that the one event happening doesn't change the probability of the other event happening, we can just multiply those two probabilities together. And that's what we did in our introductory lesson. Now, if those events are not independent, then we need to do something else. So we're going to multiply the probability of event A happening by the probability of event B happening, given that A has already happened. So that means that event A happening is going to change the probability of event B, and so we need to use this conditional probability because they're not independent events. So take a second to read this scenario. So we have two different types of batteries manufactured here. We have regular batteries, and then we have the rechargeable type. And it says that the company has 2% of their regular batteries defective and 1% of their rechargeable batteries will be defective. They also tell us that the rechargeable batteries make up 25% of the company's production. So what that means is that regular batteries make up 75%. So we want to find some probabilities. So the probability that if we take a random battery, choose a random battery, that we get a defective rechargeable battery. So we're looking to see what is the probability that we have a rechargeable battery and it's defective. So I'm going to use R for rechargeable, D for defective. Since these things are not independent, I'm going to multiply the probability of being rechargeable, which is 25%, by the probability of being defective given that it's rechargeable, which is 1%. And I found out that the probability of choosing one battery at random that is a defective rechargeable battery is about 0.25%. So remember that on a quiz or a test or a homework, you should report this to me using a sentence, writing the answer in context. What's the probability of a regular battery and it's not defective? So I'm using B for regular battery and D for defective, and I do DC because we're looking for it to not be defective. So we're looking for the complement. So the probability of a defective battery or a regular battery was 75%. The probability of a defective battery, given that it was a regular battery, was 2%. Therefore, the defective complement is 98%. When we multiply those together, it's a 73.5% chance that a battery chosen at random is a regular battery and it's not defective. So we have something that changes in probabilities here if we take out an option and don't put it back in. So we have this scenario here where we're randomly drawing for dorm rooms. There are 12 rooms left, and there are 3 in the gold hall, which is the place you really want to live. So the first time somebody draws, there's 3 chances out of 12 that you'll get a gold hall room. But if the next person draws and the first person had already drawn a gold hall room, then the probability of getting a gold hall room has diminished. So if you draw a gold room on the first try, there's only 2 left, and there's only 11 rooms left total. So the probability of your friend getting a gold room on the second draw is 2 out of 11. We've already picked 1 gold room, and we've already picked 1 room in general. So this is a conditional probability. It's the probability you draw a gold room given that somebody else already has. So we want to know the probability of drawing a gold room and your friend draws one. So that means the first two rooms are gold. So we're looking for the probability of getting a gold and a gold, which is the probability of getting a gold times probability of getting a gold room, given the first one was already gold. So we take our original 3 out of 12 and multiply it by our 2 out of 12 because we didn't replace that room. And we get that it's about a 5% chance that you and your friend both get a gold room. So here we have a bag of Skittles, and I've given you the breakdown of the colors of the candies and how many there are in this bag. We want to know the probability that you shake out 2 Skittles, and your first 2 Skittles are both orange. So the probability of drawing an orange and an orange. And so once we take one Skittle out, we're not putting it back. So these aren't independent events. My first event affects the probability of the next one. So the first probability of drawing an orange is 5 out of the total 20. And then since the first one was orange, we only have 4 left out of the total 19. And when we multiply these together, we get 20 over 380, which means we have about a 5% chance of getting 2 Skittles that are both orange in a row. The next one, we want none of our first candies to be green. So we're looking at the complement of drawing a green Skittle. Well, we have 7 green Skittles, so that means that the probability on the first try of getting something that's not green is 13 out of 20. The probability of the second try, because we didn't put that candy back, is 12 out of 19. And so when we multiply together, we have about a 41% chance of getting 2 candies that are not green. Okay, the only other thing I want to talk about here is using tree diagrams to represent probabilities and answer questions. So we've already used Venn diagrams, we've used contingency tables, and now we're going to use tree diagrams. So here we have some highway safety studies saying that 77% of all accidents, a driver was wearing a seatbelt. And so that means that in 23% of the accidents, the driver was not wearing a seatbelt. So we can start building our tree. Accidents are what we're talking about, and we can break them up into subgroups: wearing a seatbelt, not wearing a seatbelt. And I've labeled their probabilities. We also know that 92% of the drivers were not injured, but 92% of the drivers escaped serious injury, but 63% of them were non-belted drivers. We're looking for the probability that a driver involved in an accident was seriously injured. And I'm sure after reading that, somebody's going to get on my grammar. So I'm gonna break these down into further subgroups: my seat belts and my no belts. So I had 92% of my seatbelted drivers were okay, and that means 8% were injured. 63% of my no belt drivers were okay, and 37 were injured. 37%, that is. And so now we can find probabilities for these 4 categories. And these are our and probabilities. The probability that somebody was wearing a seatbelt and injured. The probability somebody was wearing a seatbelt and was okay. So if I do the probability of seatbelt and injured, that means I take my probability of wearing a seatbelt, which was 77%. The probability of being injured given that I was wearing a seatbelt, that's 0.8% or 0.08, so 8%. Multiply those two together to find out that the probability of selecting a random driver that was wearing a seatbelt and injured, 6.16%. So if I look at all this work I did over here, all I really did was multiply these two numbers together, my 0.77 and my 0.08. So if I follow that pattern, I'm going to multiply 0.77 by 0.92 to get the probability I select a random driver that was wearing a seatbelt and was okay. Same thing here, I can do 0.23 by 0.37. 8.5% of my drivers were wearing no belt and they were injured. And finally, 14.49 or about 14.5% of my drivers were wearing no seatbelt and were okay. So what we really wanted to find out was the probability that a driver was involved in an accident was seriously injured. So I have people who are injured and wearing a seatbelt. That's 6.16% probability. People wearing no belt and injured, 8.51% probability. So I'm going to add those two probabilities together and get that the probability of a driver being involved in an accident and being seriously injured is 14.67%. We can also use that to find a conditional probability. I want to find the probability that somebody was wearing no seatbelt given that they were injured. So we have a driver who's injured. We want to know the probability that they were not wearing a seatbelt. So this is back to what we talked about last class. We have to find the probability they were injured and not wearing a seatbelt. That's right here, 8.51%. And the probability that they were injured. That's what we just found, 14.67%. I use the decimals, of course, do that division, and we get that given that this person showed up in the emergency room and was injured in an automobile accident, there's a 58% probability that they were not wearing their seatbelt. So the moral of the story is you should wear your seatbelt. So I want you to try these two problems. It could be on a half sheet. It could be on a full sheet. I want you to hand it in to me at the beginning of class. Do your best. If you can't get them all, that's fine. This is just a checkpoint, something that'll show me how much you got out of the lesson. And we'll have plenty of time to practice and answer questions.